Solution. In this chapter, we will discuss about a homogeneous equation. Solution of homogeneous equation. Homogeneous equation means these constant terms are zero. a11 x1 plus a12 2 plus etc. a1 and xn equal to 0. Similarly, a22 x2 etc. a2 and xn equal to 0. These constant term will be 0. Such equations is called homogeneous equation. This homogeneous equation we can write down the matrix form. Coefficient terms are matrix A and variable matrix are matrix X and constant matrix is a zero matrix. In the case of homogeneous equation, we can say augmented matrix. Augmented matrix. Augmented matrix. What is augmented matrix? We can write down the right side of the coefficient matrix. We will make a constant matrix. But here constant matrix is a 0, 0 matrix. Therefore, we can write down here coefficient matrix on the right side 0, 0. We can get A itself. That means augmented matrix and coefficient matrix are same. That means augmented matrix and coefficient matrix are same rank. Therefore, homogeneous equations are always consistent. Therefore, always exists a solution. Always exists a solution. At least one solution. One solution is 0, 0, 0 is a solution because we can give x1 equal to 0, x2 equal to 0, etc. xn equal to 0. This equation will be 0. Similarly, next one will be 0. So, all equations are 0. We will give x1, x2, etc. xn equal to 0. We got these solutions. Therefore, 0, 0, 0 is a solution of homogeneous equation. This zero solution is also called trivial solution. Trivial solution. X equal to 0 is a solution of system of linear homogeneous equation, so which is called trivial solution. Next one of the theorem, a homogeneous system of equation, m equation and n unknowns, m equation and n unknowns possess non-trivial solution of m equation is less than n variable. We have m equation and n unknowns. Unknown is greater than equations or equation is less than unknowns. We can say such a system of equation possesses non-trivial solution. Augmented matrix and coefficient matrix are same. So, system of homogeneous equation has at least one solution. I already said. I think all of you understand why homogeneous equation has at least one solution. Why augmented matrix and coefficient matrix are same. Why homogeneous equation are consistent. Homogeneous equation is consistent means augmented matrix and coefficient matrix rank are same. Augmented matrix, how to get augmented matrix? Augmented matrix will get right side of the coefficient matrix we write down the constant terms in the column. But here constant matrix is a zero matrix. So we can write down the right side of the coefficient matrix is 0, 0, 0. Therefore, augmented matrix is same as coefficient matrix. Problem: x minus 2y plus 8 minus w equal to 0, x plus y minus 2z plus 3w equal to 0, 4x plus y minus 5z plus 8, y is minus 7y plus 2z minus. So first of all, I write down these four equations, coefficient matrix. First write down coefficient matrix, and constant matrix is a 0, 0, and variable matrix is x, y, z, w. And in the case of homogeneous system of equation, augmented matrix means a minus 0. Augmented matrix is same as coefficient matrix. So rank of augmented matrix and rank of coefficient matrix are same, because augmented matrix is same as coefficient matrix. So augmented matrix rank and coefficient matrix rank are same. So system of homogeneous equation is always consistent. System of homogeneous equation. System of homogeneous equation is always consistent. So we have to check its a solution. Therefore, homogeneous system of equation is always consistent. Therefore, there exists at least one solution. In the case of homogeneous equation, there exists at least one solution. Next, we take the coefficient matrix and we can solve equivalent the coefficient matrix. We need to make equivalent coefficient matrix. So first term a11 position we stay as 1 and below we need to make a 0. So we did these operations. R2 minus R2 changes to R2 minus R1. R3 changes to R3 minus 4R1. R4 changes to R4 minus 5R1. So first row is same as itself. So write down 1 minus 2, 1 minus 1. And second row is R2 minus R1. So 1 minus 1, 0. 1 minus minus 2, 3. Minus 2 minus 1 minus 3, 3 minus minus 1, 4, and 4 minus 4. Third row R3 minus 4 R1. So 4 minus 4, 0, 1 minus 4 into 2 plus 8, 9, minus 5 minus 4 minus 9, 8 minus minus 4, 12. Fourth row 5 minus 5, 0. R4 minus 5 R1. 5 minus 5, 0, minus 7 plus minus 7 5 into 2, 10, minus 10, minus 7 plus 10, 3, 5, 2, minus 5, minus 3, minus 1, plus 5, 4. So we got this. 1 minus 2, 1 minus 1, 0, 3 minus 3, 4, 0, 9, minus 9, 12, 0, 3 minus 3, 4. So next A22 position we need to make 1. So R2 divided by 3. R2 changes to R2 divided by 3. So we got all other rows are same as itself, and R2 will become 3 by 3, 1, 0 by 3, 0, 3 by 3, 1, minus 3 by 3, minus 1, and 4 by 3. So all other rows are same as above. Next we need to change in the above and below position we need to make A22 positions above and below position we need to change 0. So here minus 2. So R1 plus 2R2 minus 2 plus 2. So R1 changes to R1 plus 2R2. And here 9, 9 minus 10. So R3 changes to R3 minus 9 R2. Here 3, 3 minus 3. So R3, 4 changes to R4 minus 3 R2. So we got minus 2 plus 2, 1. 1 minus 2. 1 minus 2. Minus 1. Minus 1 plus 4 by 3 into 2. Minus 1 plus 8 by 3. Minus 3 plus 8 by 3. 5 by 3. Next 0. To make a 3-2 position will make to 0 and a 4-2 position we make to 0. So we take these two operation R3 minus 9R2. R3 changes to R3 minus 9R2 and R4 changes to R4 minus 3R2. So 0 minus 9 into 0 0, 9 minus 9 0, minus 9 minus 9 0, 12 minus 12 0. Next 3 minus 3 0, minus 3 minus 3 0, 4 minus 4 by 3 into 3 0. So we got third row and fourth row will be 0. So we got this matrix 1 0 minus 1 5 by 3 0 1 minus 1 4 by 3 0 0 0 0 0 0 0 0. So our coefficient matrix equivalent matrix is this 1 0 minus 1 5 by 3 0 1 minus 1 4 by 3 0 0 0 0 0 0 0 0. So we need to find A is a coefficient matrix. We need to find Ax equal to 0 solution. This equation solution. But A is equivalent to B. So we need to make, we need to find the solution of Bx equal to 0. Solution of this is same as solution of Ax equal to 0. So A is equivalent to this matrix. So we need to find the solution of this matrix into x equal to 0. That is same as Ax equal to 0. So we write down the x matrix and equal to 0 matrix. We get multiplication if possible. We multiplied these two matrix. We got x minus z plus 5 by 3 w equal to 0. Y minus z plus 4 by 3 w equal to 0. We got two equations and x, y, z, w, 4 unknowns. Two equations and 4 unknowns. So we have to write down the arbitrary constants. Otherwise, we have to take arbitrary constants. So here two equations and 4 unknowns, because 4 minus 2 arbitrary terms we need to take. The two arbitrary terms we need to take. So I would like to take z equal to a and w equal to a. Any variable we can take. X equal to y equal to. We need to take two variables. We have to take any variables. So I would like to take a z and w. Z equal to a and w equal to b. So we got x minus a plus 5 by 3 b equal to 0. Therefore x equal to a minus 5 by 3 b. Similarly y minus a plus 4 by 3 b equal to 0. Therefore y equal to a minus 4 by 3 b. So we got x equal to a minus 5 by 3 b, y equal to a minus 4 by 3 b, and z equal to a and w equal to b. So we got the solutions in the arbitrary terms. A and b are arbitrary terms. We can take a equal to 1, b equal to 1. So we got one solution, x equal to 1 minus 5 by 3, y equal to 1 minus 4 by 3, z equal to 1 and w equal to 1. This is the one solution. Similarly, we can take a equal to 1 and b equal to 2. So we got other solution. Similarly, a equal to 1 and b equal to half you can take. So any a and b in real number, you get x, y, z, w. Therefore, we have infinitely many solutions. Infinitely many solutions. In this homogeneous equation, we have infinitely many solutions. I will say one theorem, otherwise one note. We have m equations and n unknowns. Unknown is greater than number of equations. Number of unknown is greater than number of equations. we have to take arbitrary constants. N minus m arbitrary constants. Here we have 4 unknowns and 2 equations. So we have to take 4 minus 2 arbitrary constants. 2 arbitrary constants. So one more example I will say. We have 9 unknowns and 6 equations. So we have to take 9 minus 6 arbitrary constants. So first of all, we did we find out the equivalent matrix. First of all, we need to find the equivalent matrix of coefficient matrix. Then how many rows are 0? So that equations are minimized. So number of equations are non-zero. Number of equations is equal to number of non-zero rows. Therefore, find out the number of unknowns and find out the number of equations, and number of equation is less than number of unknowns. We have to take arbitrary constants. Number of how many arbitrary constants we will take, that is the 9 minus 6. So m equations and n unknown. Unknown is greater than equations. We have to take n minus m arbitrary constants.